All right, this is chapter 3, section 2, problem 27. In 2011, the mean rate of violent crime per 100,000 people was 24. Particular states was 468. The standard deviation was 183. Assume that the distribution was unimodal and symmetric. Recall that the empirical rule states that if a distribution is bell-shaped, then the following are true. So unimodal, one mode, and symmetric on both sides. Approximately 68% of the observations fall within one standard deviation of the mean. That is between x bar minus one deviation and x bar plus one deviation. So plus or minus one deviation, 68% of the data. (68% of the data fall right in here. Approximately 95% of the data fall within two deviations of the mean. So that'll be x plus two deviations or x minus two deviations from the mean. So this is one deviation there. Then a second deviation would be there. So 95% of the data would fall right in here. That would be 95, and this would be 68% of the data. And nearly all of the deviations fall within three deviations of the mean. It was like 99.7, I believe. Then they ask you here, how is the number 6? How is the number 6? 51 obtained. So we see that it's just one deviation above the mean. So it'll be x bar plus one deviation, 1s, which would be 468 plus 183 will give me 651. That's one deviation above the mean. Okay. 651 was obtained by adding one deviation above the mean. So what are the crime rates for A, B, and C? So you can see where they are in relation. They're on deviation points here, so you'll be adding and subtracting to get to it. So C is here, and that's two deviations above the mean. B is here, and that's one deviation above the mean. And A is here, and that's two deviations below the mean. So for A, it's two deviations above the mean, below the mean. So that's going to be what? X bar minus two deviations, or 468 minus 2 times 183. That's what that comes from there. And for B, it's one deviation below the mean. So that's going to be x bar, one deviation below the mean, minus one deviation. It'll be 468 minus 183. That's how that comes into play there. And this last one here, C. The C is located two deviations in relation to the mean. The mean, the average there is 468. So I'll have here x bar plus two deviations above the mean, standard deviations above the mean. So that's going to be 468 plus 2 times 183, and that'll give you that number there. between two values, would you expect to find 95% of the data? So remember we said earlier that 95% of the data would fall within two deviations of the mean. That would be put it right between, it's one deviation, two deviations, right between A and C. And we found A to be what number? Two deviations below the mean, which is 102. And two deviations above the mean is 834. Okay, so we can find that 95% of the data will fall between 102 and 834. Between would you find 68% of the data? So 68% of the data we see right there is going to fall between one deviation of the mean. So for B here, below one deviation below the mean, that makes that 285. And one deviation above the mean is at here, 651. So 68% of the data is going to fall between 285 and 651. If one of the part C, if one of the crime had a crime rate of 614, would that be unusual? 614, where would that fall? It would fall in here within one deviation. So unusual is more than two deviations, and we can see that 614 falls within that one deviation. It's not that unusual. It's less than one deviation away. Part D. If one of these states had a violent crime rate of 48, would that be considered unusual? So the crime rates here. So where does 48 fall within this interval here? It doesn't fall within the 68. It would be way down here. Extremely low. It doesn't fall within the 95. That would be 102 to 134. So it's more than two deviations out. And so it would be considered highly unusual there.